This way. All right. Well, welcome everybody. Thanks for joining the September edition of Cloud Native Madison. Happy to have you here. Quick retrospective on last month. Thanks again to Jürgen Etzelsdorfer for presenting on Captain. It was a really cool demo, and Jürgen has obviously put a lot of work into that. It's a very exciting new project with a strong community behind it. If you're interested in checking that out, like all of our meetups, we do post those out on our Cloud Native Madison YouTube channel. And if you subscribe to our channel, you'll get notifications whenever we post new meetups. Also wanted to point out, just as I was looking around at what's kind of happened in the community over the last month, that Captain was also featured on the Kubernetes podcast from a different key contributor there. So if you want to learn more about Captain than we talked about last month, go ahead and check that out. So looking ahead, we're going to have next month's meetup on Thursday, October 1st. We're kind of finalizing talks with a speaker for that. Hopefully we'll have that nailed down by tomorrow, and then we'll go ahead and get that posted out on the meetup site. But as always, we're always looking for speakers. Whether you're local to the Madison area or from further afield, we'd love to hear from you. And we'd also love to hear from members, if there's specific topics that they'd like to see covered. Because, one of the advantages of sort of the current, COVID world we're living in is it gives us a lot more opportunities to pull in folks who may not be able to make it on site when we do return to normalcy there. So yeah, again, love to hear from about any topics you're interested in, and love to hear if you have an idea for a talk. So typically we go ahead and go through what's been happening in Cloud Native, and specifically, kind of showcase what projects have been doing in the space here. So we're going to talk about a couple of projects today, and just for folks who haven't seen this before, so you know kind of what we're talking about, the CNCF has what they call their maturity model, and that defines kind of three different levels that a project can be in, starting at sandbox, moving into incubating, and then finally going on to graduated. And that represents not only a level of sort of investment from CNCF to make sure that they're being good stewards of those projects, but also sort of it reflects the adoption within the community, the health of the project. To get up to the graduated level, those projects actually go through security review, governance review to make sure it's not just tied to a small group of people or one company and things like that. So graduated is the point at which they're essentially saying this is ready for mainstream enterprise use. The projects sitting in sandbox and incubating are working their way up to there, and may get there, may not. But wanted to showcase a couple of projects that have kind of come into those levels this past month. So the first is that K3S has been accepted into the Cloud Native Computing Foundation as a sandbox project. And for those not familiar, K3S was actually done by Rancher, which was recently acquired by SUSE. And the goal there was really to kind of strip down Kubernetes to just its minimum that you would need to do the basic kind of container orchestration activities, and to package it up as thinly as possible. So K3S is actually just one binary that will get you a functional Kubernetes, control plane, and you can really easily build a cluster with that. So the applications for it, aren't necessarily in the data center, right? They're more at the edge or in Internet of Things devices. Or the thing that I'm really excited about with it is, as a way to actually test your workflows through Kubernetes in a CI system, right? So you can actually spin up, essentially a small Kubernetes cluster if you're building things like operators or just anything you want to be able to actually test a Kubernetes workflow through. K3S should make that a whole lot simpler. So check that project out if you haven't already. Two, kind of closely related projects that graduated into incubating. One is Cortex from Weaveworks, and the other is Thanos. Both of these projects are trying to solve a similar problem, and that's really sort of the operational and scaling issues with Prometheus. So they both give you a way to enable better durability and kind of longer lasting indexes of those metrics that you collect into Prometheus, and then you want to use for your operations, or being able to look back over time and see how things were performing and those kind of things. I think when they picked the name Thanos, that was before Endgame, so trust me when I say it does not delete half your data, but they're both exciting projects, and glad to see them moving up into incubating. The last project I wanted to touch on briefly that actually went all the way up into the graduated level is what I thought was pronounced TIKV, but actually it's Titanium KV. And I just looked at this today, and it's a really cool project. Essentially what it is a distributed key value database, but that brings in all the sort of ACID transactional qualities of a typical relational database, to that KV store. And it looks like it's actually in use at quite a few large companies now, including EA and a couple of other large, online service companies. So I'll definitely be checking this out. Essentially it looks kind of like a Redis on steroids. Brings a lot of extra capabilities to sort of your traditional KV store. So happy to see that moving into graduated as well. And maybe we can even get somebody to give a talk on that the next year, because I think that's a really, really cool project. That's the end of our highlights for this month. As always, we want to thank our sponsor. In this case, it's Integral. So Kurt and I both work at Integral, and in addition to allowing us to use their meeting infrastructure here for these virtual meetups, they also give us time to actually coordinate and plan out these meetups, as part of our jobs at Integral. And so we really appreciate them supporting, this community and all the good speakers and talks that we have here. And with that, I want to give a warm welcome to our co-organizer. You all know him, my friend and yours, Kurt Roekle, to talk about gRPC-Web.
Thanks, Brendan. I'll get my screen shared here. I will apologize ahead of time for everybody. As I put this presentation together, I didn't time it so well, so we might go through it pretty quick. But I do have samples. I have some links in the slides here, sample applications that are going to go over this, and I'll put those in the meetup event comments as well, so people can go look at that, maybe in a little more detail than what I can do right now. But hopefully we'll get through all of this. So again, this is gRPC-Web in use. So a guide to starting streaming data to your browser applications. 7 easy steps. I didn't actually count the steps, but I did count the slides, and we're over 25. So again, I'll move quick through this, but what I want to do is highlight all the pieces of that is. And so we start out, well, I'll start out with me, Kurt Roekle, 20 years of experience, but I'm really bad at making visually appealing applications. And I say that because I'm going to show a sample application that we're going to do, and it's going to look ugly, but it's the functionality that we care about here. So what is gRPC-Web? So it is a JavaScript implementation of gRPC for browser clients. You can think of it as an alternative to both REST and WebSockets. So it's a way not only to stream data out to your browser apps, but you can use it for regular RPC calls as well. And what that does is sort of simplifies your application. You're sort of working in one paradigm to get both your streaming and your data back to the applications. So that might you might then question, well, what is gRPC? And so gRPC is that cloud native project that we're talking about here. It was an original framework originally developed by Google. I think it's probably about 15 years old at this point from the internals of Google when it started. It is HTTP2 based. When I say that, I'm saying the gRPC itself is. We'll see as we get a little into it, that causes a couple of things as we get into the web portion of it. It uses protocol buffers. We'll show the V3 in all the examples. It will use V2 as well. But what protocol buffers do, if you're not familiar with it, I'll show you plenty of samples of those, is it defines your contract of your service. And then off of that contract, it's actually going to generate some classes and services, based off of those profiles. And I'll be the first to tell you, I am not a fan of code generation. I've always, sort of stuck away from it. Never really, liked a lot of code generation that happens. But in this case, I think it's done pretty well, and it's a huge time saver, as you'll see as we go through this. If you want to get more information on gRPC, there's a link there. grpc.io is the official site. And so what gRPC itself supports 4 different types of services. Unity services, that's, basically your request response type thing, what we're all used to in a REST type thing. Server streaming, which streams responses back from the server. So one request from the client to the server, and that stream comes back from the server, and it can stream forever at that point. Client streaming, so you can stream from the request, just keep shooting things out, and then get a response back from the server. And then the the ever cool bidirectional streaming, where you can actually stream from the client in the server over that same channel, and it's real good. Now, as we start talking about gRPC-Web, gRPC-Web and the version that I'm going to show you here only supports these first two types. But for the most part, for your web clients, these are the most important types, and I think that should do for most of your applications. And there's nothing to say you can't even have two streams going on in the same browser application, or just fire off other requests. And you'll see the sample app actually does some of that. So getting right into that sample app, and this is what we're going to see here, is, of course, if you're doing some streaming out to the browser, you're going to write a chat app, and that's exactly what I did here with this. It is a very simplified version of the chat app, and there's actually no persistence to it as well. But I actually have a live link for you as well if you want to play with it. If you have a couple of screens right now, you can actually even jump into it right now if you wanted to. And like I mentioned earlier, all of this I do have out of my GitHub. It's basically comprises of a service on the back end, and then the front end is a React JS application. And again, that chat.kurtspace.com, you can go out to right now and actually use that chat app. But if you don't have two monitors, you probably want to watch what I'm doing as well. So the basic architecture that we're going to be dealing with here is, for a local setup, it's going to be, we're going to have our React front end. We have to go through an Envoy proxy, more on that a little later, and then back to a Java service. Now, the protobufs in the gRPC supports a wide range of languages and whatnot. I was going to re-implement this and go for this. I just didn't have time for this presentation, but I might put that out on my GitHub site, in a little bit, just to show that. But it really, you can generate these for a wide range of languages and whatnot. So as we move on to deploying into Kubernetes, the architecture looks, fairly much the same, but I should have said, Kubernetes and Istio, because it is dependent on, having that Envoy proxy in there. And that's what that sidecar on that Java service is that Envoy proxy. That'll do some of the necessary things that we need to use gRPC-Web, obviously going through the Istio ingress. So that's what I'm going to demonstrate and get into. So we'll start with the protobuf itself. And so if you may not be familiar with this, but the protobuf is actually rather simple to understand when you look at it. So you can define a service in there, and I call that the chat service, and then you just define your calls within that. So our main call that we're going to be using is that register and stream. Basically, it takes a registration object, and it's going to return a stream of chat results. So it means the client can expect that server to send multiple versions of that object chat results back. And then the other examples that you see in there are non-streaming examples with that. We'll use those throughout the example as well. And so the rest of the protobuf file then, this isn't the entire file. I'll switch over to it in a second. But you can define, any number of types with that. Ultimately, you get down to the basic types of your strings, your ints. There's about 15 different or so types that you could use within here. But just like in most services, your basic ones of string, int32, stuff like that will get in there. Important thing is when you define any enum, like what I'm doing there in that first object, you have to have a 0 as that first element in that. But beyond that, there's not much required in there. And then as for the person object, you don't need a 0. But the numbering of those is important. So protobufs in general are meant to be backwards and forwards compatible. And so it's important. I can go in here and change the name of any one of these things, and it's not going to affect it whatsoever, the actual execution of that protobuf, as long as the number and the type are the same. So in this case, in that person object, that name field is a string, and it's at that first position. As long as you keep that okay, that's fine. I can even drop that that first position out of there, and it still doesn't affect it. Everything is meant to be optional within a protobuf file. So if it's not optional, we have to deal that in a little different way. But everything that you see in here is optional. One other, that chat results, that streaming result that I got back, there's one other thing that I want to point out with protobufs within here is that one of. So that one of is just stating that you'll either get a message back or a people object back. And you won't be able to send both in there. So that's another one of those, it's a little special case, and you maybe won't use that normally in a normal application. You might want to be a little more targeted as to what your streams are doing. But at the same time, I sort of wanted to show the example here just within code, and so what you can do with that. And again, the repeated, when you look at the people object, that repeated just means it's a collection. So you're going to get a collection of persons back within that object for that. So that's pretty much, those are the basics of the protobuf within there. There's obviously a lot more, and for whatever reason, I didn't throw a link in here, but you can search that. And there's a lot of good documentation out of protobufs. Just remember, you probably want to use version 3. Version 2 isn't officially deprecated, but they're certainly moving away from it. So with that, then, after we have that protobuf, like I said earlier, based off of that protobuf, we generate code. In my examples here, we're going to start with the server side of things. Oh, one thing I just did want to jump over to the actual protobuf file. So this is the actual protobuf file that we're using. Again, I showed most of it in the examples. In here, I did add another ping. One other important thing when we look at a protobuf file is this package. This is what makes it sort of unique. And within your system, you can do that. And there are some optional options up on the top for that are language specific. Since we are using Java for the server side of things, I put a package in there. When it generates the code, it's going to generate into that package. You can also do imports of other protobuf files. Google provides this empty one for some of these messages that aren't returning anything here. Just a little empty object, because you can't just leave it blank as far as the return. So like I said, we are doing a Java application, so I'm using Gradle here. And so there are good plugins for Protobuf and gRPC in there. And so this is essentially what you would need to, the extra pieces that you need in your Gradle file here. There's that plugin there. I think all the numbers in here right now are the latest ones that are currently out there. But you define your gRPC version and your Protobuf version. Those are versioned differently. They are two separate things. And then the dependencies that you see at the bottom are the required dependencies as you bring this stuff in. And then a little special, and I haven't used the Maven plugin to this. There's also a Maven plugin. And it might define this a little bit better, but with this anyways, in Gradle, we sort of have to expose out those tasks. And this is sort of code that's doing that. And then adding that generated packages into our compiler or into the class path so we can compile against that stuff. So those are the basic setups as far as generating that. And then you can, within Gradle, there is, if you're using an IDE version or whatever, it'll bring out a task of generate proto. And so that's what you would use to generate those protobufs. It is dependent. Your build is also going to do, if you hit build, it's also going to run the generate proto. But obviously, you want to generate the protos, the files off of that before you start coding, else you won't have anything to code to. So our basic code of when we implement a service, it actually will give us a base class. So that chat service impl base is part of that generated code. And so we want to extend that to make our service with that. And then within there, we override, and I missed the override annotation in this example here, but we override register and stream. And so as we if you match that up to that protobuf file, it was that register class that was being passed in, and then you're always going to code to a stream observer of the type that you're getting back. That was defined in that file. And again, this is a streaming one, but you'll see in my next example here, it doesn't matter if you're streaming or not, you're always going to use that stream observer to respond to. And so that first check there is, like I said, everything is optional within that protobuf. So if we expect that request object to have a person into it, it does give us nice convenience methods there for checking to see if it has it. But if it is, then we want to throw an exception because we're saying this is required. So we have to deal with that within code here. And so to throw back a error to the client, it's just a response observer on error. And then we throw a status runtime exception. There's a couple of different formats to status runtime exception. One will take another exception and whatnot. But this one takes statuses, and there's a nice status object that they give you, and again, an invalid argument. Now, that's one of the key differences if you're used to programming in a REST type API situation. Where you're used to using those HTTP status codes or whatnot. And so that's a little bit of a difference with that. And I think I have that sort of at the end of the presentation of one of those things that, it takes a little getting used to. And I don't think they're as nice as the HTTP status, response codes for REST. Or maybe it's just I got to get a little more used to it. So in this case here, we have a store object, which is, it's not an actual store. Like I said, it's just holding it in memory right now. But, think of this as whatever streaming technology would, because this is a streaming response here. We want to have some sort of, streaming storage for this, or maybe even chain another gRPC call to something else that's a stream. And be listening to that and then responding to those things. So in this case, I'm sort of simulating, some streaming storage. I know in the past I've used Redis, has a nice streaming interface there. Obviously Kafka, if you're going to use something like that. So there's many opportunities to do that streaming, or you might even start up a thread and just do some polling within your service here to sort of, trigger, some of these events. But then when you do want to send back an event, then you have that response observer on next. That's down there. You'll see, towards the bottom there. And then so you can call on next as many times as you want on that response observer when it is a streaming response. And so this will fire off every time. In this example, when the set of people changes. And then it's going to send that back. Like I said, this one is set up to send back both that people object and the messages themselves. And if I'll quickly switch over to the actual code for that service again, and you'll see the actual service code. Here's a little more. So this is where we're doing that, what I showed in the example. And then we would also have that on message. So if there's a message object coming back, then we can send that back to the browser as well. So that's our streaming call there. So this now is an example of that urinary call. So we have just a single response that we're ever going to get back. Again, you're still going to use a stream observer is what that method takes in that it generates for you. You call that on next once, and then you call it on completed. And so that onCompleted is going to shut down that channel between the server and the client, and everything's going to work well. Now, you can also do that. I don't show that in this case, but you can also do that with your streaming response. So even though you're doing streaming, you might not want to stream forever. You might just be streaming because you have some slow running processes that trickle some data through, but you're not really keeping it live forever. So then you would stream until you reached all the objects that you wanted to send back, and then you call it on complete. And then that signals to the client to not expect anything else to come through. But in this case, we are just sending that one object through, call the on complete, everything's good. And so for the service side of things, that's pretty much it. So that's sort of equivalent to what you would do in a REST situation. The other nice thing about both the generated code and the included packages that you bring in for gRPC is it does include an embedded server. I believe it's based off of Netty, that you can fire this up with. So my actual implementation here just fires up, I can run this as a regular Java application at this point in time. No need to put this into any sort of other container for this. And so all I'm doing here is defining the port, firing up the server, and then just awaiting the termination until, everything shuts down. So basically when it gets a shutdown situation, and all we do here have to do is add our service into there. So our chat service, that's what we saw before. It's just defining the service that this server is actually implementing. This protobuf reflection service, I probably should have taken it out for this example. I was trying to get that to work, but it's more of a, it's just what it's saying, reflectively trying to find that proto file that defines the service here. So again, if we go back to the server, so the server is really nothing more than what I showed there. If you're going to do some dependency, I took dependency injection out of this altogether, but if you're going to do that, you want to fire up your dependency injection in here and actually create that service, inject that into here so it gets all the injection that it needs. But to keep it simple, I left that out. And so there is, some extra blocking logic in here, but it is pretty simple to fire up that server and run it. And so at that point, you can test it. Now, the tools for testing gRPC, I would have to say, are not nearly as nice as testing your REST web services at this point. BloomRPC is the best thing that I found out there so far. And I would say it's adequate for testing gRPC calls, but it's still not ideal and not as nice as your REST services, especially how it organizes all your calls. So what you would do in this is you actually import the protobuf or the proto file, and then it gives you that definition that's out there on the left. So based off of that chat proto, and again that chat service, and you see that whole package name on that service, and that again was defined out of the proto, that v1 chat service, and then you see the 5 RPC calls that I have in there, and you can see. At the top, you put in your port, your host name and port, and it's important to have the port in here. I'm guessing there probably is a default port. I'm not exactly sure what it is. I'm always defining the ports myself, so you want to make sure that that's in there. And it tells you this is a server streaming call to that. And I probably should have, the example I probably should have left, it was streaming. So if it was streaming, the green arrow there would instead be a red stop button. So you can stop it at any time. Obviously, I must have hit the stop on this. But what you would see here is right there, you have the stream 1. If there's more streams that are coming through there, you'd see stream 2, stream 3, stream 4. There's some in some of our internal applications that I'm using this in. I call one and it gives me 200 streams back because it's streaming individual objects back, and this can handle that, but it's not real easy to find what you're looking for if you have 300 streams back. So it's a little in that regard, it's a little harder to debug, especially when you're working with streams, but again, the benefit that you get with the streams, if you need it, obviously well worth it. The other thing to take note is when you're working in a client like this, even though it goes off the protobuf file, like you see the active there, that's just saying that's where that enum is based off of, and it's actually going to use the enum position. So the same number that we defined in the protobuf file. So if we look at that again, it's this offline. So in the BloomRPC, you'll be using these positions for the enums when you're setting it up in here. With that, then, in that you can test before all the specialties, but now there are some specialties because of gRPC-Web. And again, as I mentioned at the beginning, gRPC is based off of HTTP 2, but due to the browser constraints and being able to get to that level, you can't guarantee gRPC or HTTP2 out to the browser. So it has to be able to run under HTTP 1.1 as well. And so the Envoy proxy sort of gets all that settled for you. And so you don't have to deal with that in any other way. But it is important to use the proxy. And we could do a whole series of classes on, Envoy configuration. And I'm certainly not an expert in that, but these are the basics of what you have to do for the Envoy configuration. And again, my sample project has this all in there, so you can sort of take this and go with it. But the important things are obviously the matching of your service itself. And again, we see that path that's on there. Starting at root v1 chat service, again, that's based off of the package that's in the proto file in the service that we defined in there. That cluster just refers down to a cluster tag that you don't see in here, but I'll switch over to the actual Envoy config where you can see that some timeouts. Now the allow methods, I don't think you have to have all those methods in there. The only thing I've seen is post. I haven't been able to test them all, but I'm guessing you'd be fine. I should say post and options you'd probably be fine with for a gRPC-Web call. But then there are some special headers that you have to allow through the proxy, and we see that the ones that say gRPC down in there are there, and then the actual exposing of the headers also we want to expose those out so they leave that, and so the web client part of that knows that this is a gRPC and get the statuses and whatnot. And then Envoy does have a built-in filter, and so that envoy.grpc_web is that filter that's important to include into Envy to really make it all work with that. After you get that set up, then obviously you can test it in your BloomRPC again, and you can test that same call that would go out to the to your client through that. Again, change the port that you would do. So like this one, I now have defined on 9095, and so I would test that through BloomRPC on 9095. Again, when we were defining this cluster here, chat service, it's just this cluster section down here, chat service. And the one thing, and I haven't found out how to make the, when we define that in the Java service over here, when this is actually doing the bind, it's apparently binding to one IP address, my main IP address, and not to all the interfaces. I'm sure if I got down to that or knew that level of networking a little better, I could figure that out. But what that means is I can't go to the local interface. So I can't do 127.0.0.1 in here. So I have to actually put my specific IP in there. So now my IP of my home address, do what you want with it. So you don't know my external IP, so you can't get to it. So there is that, and that's something that will catch you, especially I found that, especially when I moved from my office to my home. Now I haven't been doing that much in the last 6 months, but before that point, if I move my computer from the office to the home, I always have to change that. It always messes me up a little. Oh, actually, before you even build, run, or you can test that, you can fire up Envoy on its own, but you can do just a little Docker container, and that's essentially the entire Docker file that I have right there. You're just going off Envoy latest, pull it in your Envoy config, and then adding some paths there for logging and whatnot if you want to look in and see what's going on to it. Do your Docker build, Docker run, and now you're exposing that 9095 just like I showed within there, and you can have that run. So it's really easy to fire up that Envoy proxy, and you can actually, that's the cool thing about Docker, right? You can have a bunch of those going as long as they're not on the same port. You have many different configurations set up, and by different services locally, I do have them set up for that. So essentially now we have our service that's all up and running, very testable at that point in time, and we can see that run. Now it's on to implementing the actual client side of this. So the client side, like I said earlier, I am using React in my examples with TypeScript, but you don't have to use TypeScript. Any Java or JavaScript framework will do, and we'll show it here as I generate that stuff. There is a little special tag that you have to actually generate that TypeScript, else it's going to come out in regular JavaScript. So in your package.json for your client app here, these are the things that you have to include. And again, that you only obviously have to bring in the types if you're using TypeScript with that. Else it's the protobuf, gRPC and gRPC-Web dependencies that you have to bring into this. So to actually generate that JavaScript TypeScript, there's a proto-C command, and you will have to have that installed locally on your server or on your machine to do this generation. It's really easy to install. Now I use Linux, but I'm sure, I know I saw stuff out there for Windows and Mac as well. The command itself is a little tricky. You want to be pretty careful with where you run it from and what paths that you put here. And that's some of the stuff that I'm trying to point out with this, but I'll walk through it here quick. So that first /proto that you see, so you'd want to run this command out of your root of your project. And so the proto is where I'm putting that chat.proto file for my JavaScript project. So it's in that folder. And so that is the base of the proto files. And then you have to actually specify the proto file itself with that same path again. It's a little confusing, and maybe some newer updates will make that a little better. But that's certainly something that can catch you if you're not careful as you're generating these things. Now the output, there's a couple of different commands in here. The JS out, again, you're looking at common JS up there. That's just telling it to generate the JavaScript. You can also use the proto-C command to generate for other languages as well. But I found most of the other tooling, has, especially if you're using Java, both Gradle and Maven will have plugins to build that. I believe there's other stuff in .NET to build that stuff as well. So you won't have to deal with that for this, but for the JavaScript, I haven't found anything nicer to actually generate this stuff. But then the path there, the src gen is where you want that stuff to end up. Again, that's relative from where you're running the command right now. It's not based off of that /proto at that point in time. So you're generating that into src gen off of your root of your project. And then the second command there is the gRPC. So it generates a couple different types of files, and that's what you see with both of these commands here. And then this is where the special command is when you're doing TypeScript. So now on this line, you see common JS plus DTS. And again, at the end, we're getting that path to where it's generating out to. So again, I think I touched on the points here, but you want to run this in the root of the project. Proto is the base directory of the proto file. So now, before when I showed you that you can reference, import other proto files, that's why that directory is important there. A lot of times when you're building a larger app, you're not going to have everything in one proto file. You're going to have multiple proto files that you utilize, and then it's going to look for those imports based off of that with that I parameter. And it does, this command only takes in one file to actually generate. Again, maybe that's a newer feature that they'll have with that, but I found that the star or any sort of recursive within there did not work with this command. I have a command in the package JSON that'll accommodate for that though. And then again, the difference between just JavaScript and the TypeScript stuff is there. 2 spots to generate that where the generated code goes. And an important thing that's annoying to me, and I'm sure if we have some front-end developers here, they'll be laughing at me right now, but I couldn't figure out how to turn off the linting for those generated folders. So, but you absolutely want to get that stuff turned off. And if we actually go over and look at my package.json file, you'll see all these same things. But what I've done here is, just within this, one of the scripts here, I find all of those proto files and loop through those and call that once per. And then you see my cheat in here for turning off the linting in there is I append the ESLint disable at the beginning of it. I promise you that I did try to use the .ESLint whatever file that to try to configure that and turn off that directory specifically, but it front end stuff does not love me. So with that, then now we want to implement the actual calls, back to the server from that. The important part here is that generated code that it gives you. So you can import everything that you need for this in terms of, I notice I actually missed one import, and I'll show you that. I'll pop back over there and show that to you. But so that chat protobuf file gets generated into one, and there are all those objects that we had generated and put in that protobuf file that we need for this. Now, one unfortunate thing, there are objects within that, and you can't use, you can't build them in your normal, JavaScript, TypeScript way of building that. You do have to use the methods to build all of these objects in there. So make a new person, set all the methods on there. Again, putting that within the register object. And then on that call about midway through is that chat service client. Now that's that generated client code that it's giving you. You're passing in the URL that you want to talk to. And then there's options for your options on the call is one of those nulls there. And the other one is credentials that you can pass into that client. And then you're actually, calling that method just like you had it defined in the protobuf file. Almost just like what you have defined in the protobuf file. Protobuf, by standard, you want to have capital letters, but depending on the language that it's generating for, it'll make those either lowercase. So you noticed in both Java and TypeScript here, it made those calls lowercase, even though in the protobuf file is uppercase. Another thing to take care of, but if you have code completion in your IDE, they'll pick up all that stuff. Again, you're passing in the registration at that point in time, and then that then you're getting that stream back. So you get that stream back, and that stream has different types. So it has that one on function that will get called on when something happens. And so you have your normal ones that you're going to use on a normal basis. And the most important one is what you see right there first, is that data response. That's where you're getting all your data from that's coming back, that's getting streamed back from that service. Other important ones are error and end. In this case, we don't ever end that stream, so that end will never be called. Error, if you look at my sample code, is not implemented appropriately. But since this is a stream that you never expect to end, that error, you'd probably want to restart a stream at that point in time using the same stuff from before. I didn't go to that level in my examples, but that's what you would normally do in that case. And as you can see in here, this stream call is the one that had two different message types in there. And so that's what I'm checking for here, that has text. Again, it gave us that convenience method and that object that it generated for us. That I'm doing actually, setting those messages up in the state here in the React app. And then if it's not that, then it's people. So I'm set the people up there. So essentially that's your call for that. And then your urinary call is pretty much the same at that point in time. You're doing that. There's no return from this now because it's just, that single call. So you have you're still your chat service client. In this case, it's that get active people. This is one of those calls, one of these RPCs that had an empty, and then it gives you a callback here that defines the error in the response. And again, the response is that people object that I'll set in the state. And you can see how I don't care about errors at all here because I ignore the error. But those are the two things that come back within that. And so if we look over at the actual code here again, we see all of that stuff here. And at the end of this, this is probably a little more specific to React, but I do close the stream if you leave that. And that's what this extra stuff is doing down here. But then the other thing that I didn't show in the examples, I sort of inlined it in the examples, is it is a good practice to pull out that actual setup of that chat client service out of that code. So this is in a shared service here, so it's my gRPC.services. And what I can do in here then is I do have some code in here that helps me between local development and server, when I install it in the server. And so I'll check for the host name there. If it's localhost, then I know I'm going against local. If not, then I'll give it the server URL that I'm going to. And if I was going to upgrade to, my server one is not running under HTTPS right now, but if I was to do that, I would put that. And again, remember, it's very important to have these ports in here when you use this, else it will fail as well, and you'll wonder why. So with that is you can now run your application locally like that, and it'll run fine. So that your local development is complete pretty much at that point. So now, we said we also wanted to deploy this out to a server. And so with this, all the mechanics are there if we're using a cluster, with Istio enabled with that. But there are a couple of things that we have to work on, and I'll pull out the important parts of the config here as well. Again, this is all of these configurations are all in my sample projects if you want to jump into and look a little more. So your match here, again, we've seen a couple of times now, your V1 chat service. We saw that in the Envoy configuration. So same thing here in our virtual service, we have that. Our CORS policy still applies to these things. So can we cheat and do allow origin anything? The allow headers, again, we sort of saw that in the Envoy config for our local config and the expose as well. So it's important things to add to your virtual service with that. The other really important thing that you need, is it's a new object now that you'll have to install in Istio, is this Envoy filter object. And what that is that other, I sort of pointed out when we were going through that, if you look from the bottom line there, that Envoy.gRPC-Web, filter that Envoy has into it. This is the mechanism that Istio gives to actually apply that filter within there. So this is an important object to have installed into your cluster for that. With that, it's running out on the server at that point in time. So again, and if you all want to play over, I don't know if anybody has. I have to find my right browser now. So I see a couple of people jumped out there right now, but I'll name myself hi. And so this is that working application. Again, all the source that we showed there will be part of that and make this happen just like this. And these streams you can leave open literally for weeks at a time. It's only going to crash if your server crashes, then you have to restart. But it is. These are long running. And in fact, as I was developing this, I left that one stream going all weekend, and it was still working just fine. So they are very durable in terms of going. But there are a couple of things to look at with this, and a lot of these I already pointed out. As we went through, is those status messages are not as clear as you like. They're not nearly as nice as HTTP status codes that you're used to with REST. Less granular. I think there's maybe 10, 15 in total statuses that you can send back with that. And especially when you get into some of the chaining of services, it's really hard to find out where that. And when I say chaining, I mean you're going from the web to a service, and then to a service to another service, all with gRPC. And to find out where you're broken there is sometimes a little challenging. I'd also have to say, and I didn't put it on here, but the tooling around your APM tools and stuff like that are still not caught up to where they are with the REST services at this point in time. So just detecting these transactions is a little more of a challenge in some of those tools. And it's when you're developing locally, you have to have that Envoy proxy running. And again, it's really not clear with those status codes if your problem's in the proxy or the problem is in the service itself. And so there's a little frustration that can come around with that at times as you're locally testing with that. So a couple of things to look out for. The other important thing, I showed those, on the client side, the responses that came back from the stream. And there's 5 responses in total. I showed 3 of them there. I showed the data, the error, the end. There's also a metadata, and I'm blanking on the last one. Those ones you won't use as much. But end is something that's interesting. You might think that when the stream dies, end would be called. And when I say that the stream dies, not when it's shut down with an on complete, then it's going to give you that end, and that's pretty much the only time it's going to give you that end. Status is the other one that I can send back. So it's not going to give you that back when the server goes away. And so you have to, that will come through with the error. So just a little thing to keep in mind as you're working with that. You also need to find a way to manage your proto files themselves. I didn't really call it out as I was going through it, but you saw the proto file in the Java application, but I was copying that and putting it into the JavaScript or the TypeScript application as well. And you're not using the same thing at that point in time. I found a couple of different ways to manage that at my company. What I've been doing is, generating another, basically making another project for those protobufs, and, pushing that out and pulling that in as a dependency. That works just on the server side and keeps it nice and managed there, but it doesn't help me on the JavaScript side. I've seen other strategies for still doing that same thing, checking those protobufs in there, and then generating a lot of clients off of that and pushing libraries to your different areas. So if you're using Java, you push it into a Java repo. If you're using JavaScript, you can push it into like a local npm repo and stuff like that. We haven't got to that point, but it's going to be something important as you work with this more to managing those proto files. And then, as I pointed out earlier, and it might just be me, don't hate on the generated files, right? The generated files may be a little frustrating, especially on the TypeScript side, where you have to go through all the methods instead of, maybe more, directly creating those things like you may be used to in that. But it is a huge saver of time and effort, and it actually generates a heck of a lot of value into your application by doing those. And then the other point that doesn't come up with this example quite so much, but understand your pod load when using long-running streams. And so what I mean by that, so if you have this client application out there, just like what we have here, you have this chat application, and you have 1,000 people, streaming out to that. Your one pod can probably satisfy that, and you're not going to go over any sort of CPU limits to do any sort of auto scaling within your cluster. But now say there's a big world event that goes on and everybody starts chatting at one time. That one pod now may not be able to handle that load within there. And because you have this persistent connection between that pod and the client, you're going to overload that one thing, and you're basically going to cut things off. Now, there's a couple of ways to deal with that. One is your client should always be written in a way to reestablish a connection when it's part of a long-running stream. That's certainly a strategy that'll help you as you expand out. But then you also have to do it when you contract back down in your auto-scaling events as well. So another strategy might be to scale instead of off of like your CPU or memory like you normally would in a Kubernetes cluster, you might want to stream off of your number of streams that came into there. So even though your CPU isn't overloaded at this point in time, you might want to emit that metric out to there and then let Istio scale off of a different metric, which Istio is capable of doing. And so then you can, with load tests or whatever, you can sort of see what your maximum number of streams that can come into a certain pod, and then use that as your scaling guideline from there. Again, maybe a little more advanced, and if you're not using long-running streams, it's probably not a big of a deal to worry about, but it is something that you'd have to worry about at some point in time. So with that one, we can crack open a cold one. Oh, we're not still working, still part of the workday. But either way, any questions? I know I ran through that quick, and I'm surprised that I actually finished it all up. And again, I will paste all of this stuff out on the meetup comments there, so you can go and look at it and kick the tires yourself. Any questions?
I've got one question. You touched on how there's far less status codes for gRPC than there are for HTTP. How do you indicate whether you're a teapot or not in gRPC?
I do not remember seeing that one.
Okay.
It might be a good pull request that you might want to submit to them, though.
There we go. All right. Yeah, I'm a teapot. That was great. One other question I was curious about. So one of the other nice things about gRPC, at least is the way the code is generated and implemented in Go, where I've seen it, is it also has really nice support for handling what in Go is called context, but just in general, the idea of taking a deadline or request scoped values, like let's say tracing headers and things like that, and being able to easily pass those along with the protobuf message across the wire, across API boundaries. Have you seen anything like that in the gRPC website, so you can gracefully handle, say, a timeout from the caller to the callee?
Yeah, so and that's part of that metadata that I talked about. I didn't implement any of that in this example, but yeah, that metadata is passed all the way out to the client and back and forth as well. So yep, so that can be done all the way through.
Awesome. Any other questions from the community? Okay, well, I think that brings us right up to time. So excellent timing on that. Thanks everybody for joining in this month, and thanks to Kurt for that talk. You'll find this up on our YouTube channel shortly. And other than that, have a great rest of your day, and we'll see you next month.
Cool, thanks.
Thank you. Bye.
Thanks, Kurt.